Okay, now for this sum, we need to integrate this function over this curve, which is mod of z minus I equal to 2. Okay, so we can see, firstly, let's write this as this in terms of an integral, means just rewriting it, nothing else. And we see that the points at which the function not analytic are z is equal to minus 1 and z is equal to 2. Now if you draw the diagram for this circle, its center would be at, basically if you have an equation like what do you say, z plus a plus iota b, okay, is equal to something, that this thing is the radius, okay, is equal to radius. So this is the x coordinate and this is the y coordinate basically, but reversed. Like if plus a and plus b is there, then minus a comma minus b. So similarly over here we have minus b, okay, so we could just go with, yeah, a is 0 and b is minus 1, no, so minus or minus plus, so 0 comma 1, that is our center. वैसे, so if we plot it out, we get 0 comma 1, no, so x 0, y 1, about here, and since our radius is 2, it will go till here. This is minus 1, this is plus 1, then it will go up also, it will go till 3. Yeah, I'm not really drawing to scale, but okay. Minus 1 here. Since its radius is 2 here, okay, so our 2 should be here and there will be a 2 minus 2 over here, and minus 1 should lie here and plus 1 should lie here. Okay, now if you consider our points, okay, z is equal to 2. If you see z is equal to 2 lies completely outside, no, but now if you consider a point z is equal to minus 1, minus 1 is here, z is equal to 2 is here, so z equal to minus 1 lies right over here in a region in which the function is defined, okay. So now we only need to consider this, basically this point is inside, this point is outside, so we are not bothered by that. So now we could write a function as I is equal to I'll take it as this, okay, phi of z upon z plus 1 ka whole square dz, where a phi of z is equal to z minus 1 upon z minus 2. Now we could use our Cauchy integral theorem by Cauchy's integral theorem, not phi of z, entire integral, phi of z upon z plus 1 ka square would become basically the point at which the function not analytic, so phi of minus 1 into 2 pi I upon n minus 1, n is 2, so 2 minus 1 ka factorial, which is basically 1 factorial only, and this is f dash, okay, if there's ever a power here, 2, 3, 4, so 1 less would be the derivative, so if square then first derivative, cube then till second derivative you need to find and then substitute minus 1. So here we only need the first derivative, so from this we could calculate our first derivative. We could differentiate it once with respect to z and get by using the numerator denominator rule thing, u by v rule, we'll get z minus 2 minus z minus 1, z will get cancelled. Here we'll get minus 1 in the numerator, and in the denominator we have z minus 2 ka whole square, so phi dash of z becomes minus 1 upon z minus 2 ka whole square and now we need to put minus 1 only, no, in it. So we put minus 1 in it, we get minus 2 minus 1 minus 3, minus 3 ka square 9. So basically our phi dash of minus 1 ka value is minus 9, minus 1 by 9, sorry. And now if you substitute that here, we'll get 2 pi I, we let this equal to I, so we don't need to write everything again. 2 pi, this is 1 factorial, which is basically 1 into minus 1 by 9. So our integral value turns out to be 2 pi I by 9 with the minus sign up front.